Students, we were discussing many circuits, and this is your last circuit that is given in your syllabus of alternating current chapter, that is your series LCR circuit. Alright, so we have just started the derivation, so we will continue with that only in today's class. So let's first construct the circuit of this LCR. Okay, series LCR circuit. Okay, okay. So see how our circuit diagram look like. I have also shown you before, but still I'm putting it again. This is your L part, this is your C part, this is your R part. That means inductance, capacitance, resistance. Alright, three of the components are there. Okay, yes. So this is our circuit. That is the alternating voltage applied to the circuit. Alright, this is your V, and I've also told you all what will be the value of our alternating voltage that is being applied in this circuit. And for these students, that means due to the presence of this alternating voltage, you are getting the direction of the current. Okay, you can see the arrowhead. Okay, so now students, if you just could remember that previously we have calculated the value of I, that is your current, and we have also done the derivation, we have also done the differentiation of I with respect to t. That means what are the values we have got, students? We have assumed one values of q, that is your charge. We have calculated the value of I, and so we have also calculated the value of di by dt. Okay, we have already calculated all these three values. Alright, so now students, if you just go back to the previous equation number 2. Okay, so what was the previous equation number 2, students? I will write it again. Let's see what I do. Alright, consider that equation number 2 again. What was your equation number 2? That is L di by dt plus Ri plus Q by C equals to V naught sin omega t. Alright, yes, it was your equation number 2. See, I am writing it here again. Alright, yes. Yes. So, now students, I will put all these three values, that is your q, I and di by dt, in this particular equation number 2 that I have written it here. Alright. So, let's see what will I do. Okay. So, putting all these three values in your equation number 2, our equation will become, I will explain again, let me write it. Alright, so what I did, students, in this particular equation, that means this equation, after putting all these values of q, I and di by dt in this particular equation number 2, that means this equation. Okay, so see what was there in my this equation, L di by dt. Okay, and what is the value of I? If you just go back to the previous video, I equals to omega q naught cos omega t plus alpha. Alright, and here you have to multiply it by L. Alright, yes, that was your I. What is your di by dt? Because in this part we need di by dt, that is minus omega square q naught sine omega t plus alpha. See, here is only this particular term, just you have to multiply it by L since you are having L. Understood? In this way we will go. So, suppose for the second term, that is your Ri, that means what was the value of I? I equals to omega q naught cos omega t plus alpha. See, this term is only written, just I have multiplied by R. In this way we will go. Okay, and q by c, the value of q we have assumed. Okay, that one part of that q that you will write, and v naught sin omega t as usually. Alright, so let's see what I can write in the next step. Okay, so students, what I did in this particular step, yes, so I've just taken q naught common. Okay, because you can see in the previous steps, in all the terms, in all those terms, q naught is the one of the common term. So I've just taken an omega also. Both omega and q naught were common in all the terms in my previous equation. So I can put it outside the bracket as common. So omega q naught, and within bracket all other terms. Okay, so I'm not repeating it. And here I have written just the one ditto. If you just see, ditto means just v naught sin omega t. I have not written it again. Understood? Though don't think it as numeric 11. So okay, I'm just moving ahead.